Okay, starting off a little different. We're going over homework questions. So this was number 6 on last night, which deals with this graph. Now, when you have a graph, pick out some things on the graph. Pick out some points. Like what points? X-intercepts. Okay. X-intercepts are at... Good. Now, if you pick out x-intercepts first, what form do you need to use? Factored form. So y equals a, x minus b, x minus c. Now, the x-intercepts plug in for what letters? B and c. So b can be -1 and c can be 3. Now, those are B and C. Remember, we have to solve for A, so we need just one more point to plug in for X and Y. You could use the vertex. You could use what else? The y-intercept. You could literally use any point on this red curve. Since y'all said the vertex, we'll go with that first. What are the coordinates of this vertex? 1, -4. So that's going to go in for X and Y. So now we have all the letters taken care of except for A. All right. So Y is -4. Then we have our A. X is going to be 1. B is -1. We have another 1 again for that X. And then C is 3. Now, simplify the parentheses first. So what is 1 minus -1? 2. And what is 1 minus 3? Now, next step is multiply those that are on the right side. So 2 times -2 is -4. So this becomes -4a. And then last step. So A is 1. Now remember, if A equals 1, then A equals 1 for standard, vertex, and factored. It always equals 1. But we're going to plug it back into our factored form since we started with that first. And we're going to plug in for our A, B, and C. So A is 1. B we said was -1, but what happens when we minus a negative? And then C was 3. So our factored form is 1, then X plus 1, and X minus 3. Now, I saw several people yesterday. There was a few that stayed after for tutoring too, and once they had the factored form, they converted that to standard form. So that'd be a good place to go to next, right? So how do we do standard form? Distribute. Do I really need this 1 here in the front? No, because when you multiply by 1, it doesn't change anything, right? So let's just distribute these two out. So distribute the X and you get now distribute the 1. And then combine like terms. So it'd be X squared minus 2x minus 3. All right, now that it is in factored, this is our standard. And now we want to write it in what? Vertex. Do I have to complete the square to write it in vertex? No, because if you look here, I have my vertex. And I have my A. Isn't that all that I need for vertex form? Yes. So I'm going to just plug those in. So y equals A, x minus h squared plus k. So y and x will stay. A is 1. And now instead of using this as xy, we're using this as our hk. So h is 1. And k is -4. And there is our vertex form. So on the graphs, once you solve for A, then it's just plugging into the equations. So you don't have to go again and try to use complete the square. You just plug in. 7. Is everybody okay with that if I move the screen? Is that too far? Everybody good? Okay. All right. With 7, let's do this one a different way. Instead of using x-intercepts, what else could you use? The vertex and the y-intercept. Good. What are the coordinates of my vertex? -1, 8, which would go in for our HK. And what are the coordinates of my y-intercept? 0, 6. Good. Remember, if it's the y-intercept, we have the y value. So the x value would be 0. All right, so since I'm starting with my vertex, I'm going to use my vertex form. And I'm going to plug in those numbers for h and k, and I'm going to use my y-intercept as my x and y. So 6 equals A, 0 minus -1 squared plus 8. So 0 for x, 6 for y, -1 for h, and 8 for k. Now how do I simplify this? Parentheses first. So what is 0 minus -1? 1. Don't forget the squared, so that's what we're going to do next. What is 1 squared? 1. So really this is 1a, or you could just call it a, right? If you want to leave a 1 on it, that's fine too. Now what would you do to get a by itself? So a would equal -2. Now we're ready to write our vertex form. Y equals -2 for A. X minus H. Well, H was -1, so it changed it to A. Plus 1. And on the outside, plus K, so plus 8. So that is our vertex equation. Now, again, do not reinvent the wheel, right? Use the picture. So the next thing that we have is the factored form. What do you need to write factored form? X-intercepts. Do I have my x-intercepts? Yeah, they are -3, which would be like the B, and +1, which would be like your C. So when you want to write your factored equation, we're just going to plug in. So remember, once you solve for A, just plug into the other one. If you use factored, now use vertex. If you did vertex, now do factor. So it's y equals A is -2. And it will be x minus -3, which will change to A. And then x minus 1. So the only work we need to do is for standard, and we got to distribute out for standard. So let's start distributing those. So x times x. X times -1. 3 times x. And 3 times -1. Combine your like terms. And then distribute. So -2x squared minus 4x plus 6. So when you are doing these graphs, do vertex or factored form, switch them up, don't have to show any work for the second one that you do, and then distribute to get your standard. we can only get to factored form from standard. So you can't get there from vertex form. And remember, you got to factor. I might answer your question. I know you had one a while ago, and I so skipped over you like twice. I'm sorry. Let me come back to yours. Which one did you want? Number 3? Okay. Because you said something at the beginning of class, and then I changed the schedule on you. All right. Number 3 gives us this equation, y equals 2 x plus 3 x minus 1. So what form is this one? This one is factored. So if we have factored, what do we need to do to it? Get it to standard. All right, so to get it to standard, we're going to have to distribute out just like we did the last problem over there. Look at those 2 parentheses. They're the same as number 7. Did y'all notice that? All right, so distribute them out. X squared minus x plus 3x minus 3. Combine those like terms and distribute that too. Yes. Almost, this one started out as a -2, so it's going to switch the signs, but pretty much that's it with the difference between those two. Now, this is what I wanted to show you something different with. If we have standard form, we need to get it into what form? Vertex. So we said yesterday you could do what? Complete the square. Well, guess what? There's another way that you can do this besides complete the square, because I know several of you may not like complete the square. So y'all listen up if you're not listening. A way to do it is to find the vertex of this. So look on your yellow sheet real quick. Flip it over to the front of the yellow sheet. How do you find the vertex of a standard form equation? Good, you use that equation, -b over 2a, or opposite of b over 2a, however you want to say it. So if it's in standard form, what's the opposite of b? Over 2 times 2. What's 2 times 2? 4. What's -4 divided by 4? -1. Now, what do we do with that number? You plug that in because that is the x part of your vertex. Now you need the y part. So we're going to use our calculator and plug it in. So we've got -1 store as x, and then we type in our equation exactly how it looks. So if x is -1, our y value is -8. Now, these numbers are the HK. They're part of the vertex. What's the other thing that we need when writing in vertex form? We need A. Do we know what A is? A is 2, right? Remember, the A in every equation is the same. So if you don't like completing the square, find the vertex and then just plug it in the vertex formula. So y equals a, x minus h squared plus k, or y equals 2, and it would be x minus -1, which would change to plus 1, and then minus 8 at the end because k is -8. So there is our vertex form. Because when you get in Math 3, you need to know how to complete the square. So I do need to show you the hard way because you're going to have to use it later on as well. So the hard way is going to come into play later on. So the more you do it, maybe the more you remember it. But on the test that's coming up next week, as long as you are showing your work, you're going to get credit for it, okay? So if you complete the square here, and you do that, that's fine too. If you show this work to the side with finding the vertex, that's fine too. So on this next test, there are lots of ways to find different parts, right? like to find the x-intercepts. You can quadratic formula, you can complete the square, you can factor, you can square roots. To get it in vertex form, you can work with the standard form to find the vertex or complete the square. The only thing I don't want you doing is typing it directly into y equals and finding it on that graph. That's because we need to work on getting our math skills done first. We'll talk about how to do it on the graph a little bit later. Okay? Does that make sense? All right, one other thing I want to show you. So everybody grab those calculators out. What I want you to do is I want you to type in these three equations in y equals. So we're going to type in these three equations in y equals on your calculator. I'm going to type them in mine while you guys are typing them in. Oops. Let me change that up. That was a +1. Whoops. Let me just clear those out and start over. That was the other problem. Let's see. This was number 3, so it was 2x plus 3x minus 1. 2x squared. All right, so those were the three equations that we just had. Yep, type them in y equals in y1, y2, and y3. Did you lose yours again, Luke? Stressing me out. Yeah, that one definitely won't work with typing those in. No. This is a great way to double check yourself to make sure that you're doing it correctly. So once you have all three typed in, you can go to 2 places to make sure that you did it right. So this is a good way to check yourself, check your answers that you have. So once they're all 3 typed in, if you hit graph, those 3 equations are going to graph right on top of each other. So mine was maybe a little quick to see, but it had the 3 colors there, the blue and the red and then the black. So they were all 3 graphed on top. If you hit second graph and look at your table, what do you notice about all the y values? I'll pull it back up. But all the y values are all the same. So that's how you know that you have the right 3 equations. If all the y values are the same in the table and all 3 graphs are the same when you hit graph, then you have converted them all correctly. So that's a good way to check yourself. All right, we got a couple of word problems that we're going to discuss and have that yellow sheet out because we're going to write some key things on our yellow sheet. So the equation below gives a fireworks height h in feet at time t in seconds. Find when and where the firework will reach its max height. Now, when you see this key word right here, what should you think about? The vertex. If you look on your yellow sheet, look under that column that says vertex. Jasmine will steal yours. Under this column that says vertex, we actually wrote max and min, right? So keep that in mind. With word problems, those are the key words to kind of help you out. So anytime it asks for max or min, you want to find the vertex. So let's find our vertex of this. What form is this one in? It's in standard form. So look in that column. Standard form, vertex. What do we do to find the vertex? Good. We find x equals opposite of b over 2a. So what's the opposite of b? Over 2 times a, which is -16. Now, don't forget how to simplify these. When you go through and simplify, multiply the denominator first. So what is 2 times -16? And then divide the 2 numbers. Or positive 9/4, right? Because they're both negative, so they would change both to a positive. Now, This is a word problem. So would your answer make sense to leave it as a fraction, or would it be better to write it as a decimal? Decimal. So 9/4 as a decimal is 2.25. So I just want to show you this real quick on your calculator because I saw some people doing this in first period. They typed this in as divide and then put a parentheses here, times our -16. And notice it gives you the wrong answer, doesn't it? Because your calculator divides and then multiplies by the 16. So remember the shortcut if you want to hit alpha y equals, and then you could type it in as that fraction, and it will actually give you the correct answer. So remember alpha y equals, or multiply the denominator first, then divide. Now, that's just part of the info in that box. What else does it say in the box about finding the vertex? After you do opposite of b over 2a, plug x in to find y, because we need our whole vertex on this one. So let's plug in 225, store it as x, and then type in that equation exactly how it looks. So -16x squared plus 72x plus 520. So our y value is 601. So this one asked us to find that maximum, so we found the vertex. Then let's describe what that vertex means, and we'll also answer the question. So our first number here is our x value, but in our equation, it's not called x, it's called, nope, it's called t. So 2.25 is t, and then h is in the same place as y, so that's the 601. So what is t? What does it stand for? What does it tell us in the problem? Time. So we could say at 2.25 seconds. Then what is the object that we're talking about? The firework. And the firework is at a max height. You got to use the word max when you're describing the vertex. It's at a max height of 601 feet. Is that realistic? Does that make sense? Yeah, if you think about shooting a firework off, it's going to go really high in the air, and it doesn't take long from when it goes off in the air to... Only happened a couple of times. I got burnt by a firework one time, y'all. It was like New Year's Eve, and somebody set off fireworks, but they knocked it over, and it came right at me, burnt my cheek right here, burnt a hole in my sweater. So sad. But a friend of mine, it was really funny because he was like, I'm kind of short, but he was like, I'm going to put you in front of me so you can block these fireworks from these idiots setting them off. And I was like, ha ha, real funny. And he was like, no, I did it so you could see. And I was like, oh, thank you. And then I got hit by a firework. Then he felt really bad. Yeah, he was using me as a shield. How nice. All right, let's talk about Angry Birds. How many of you have played Angry Birds before? I know it's been a while, but it's still a fun game. You know, might make a comeback. But with our Angry Birds, we have our birds that we're having from our catapults, and we're slinging them off to try to hit these little mean piggies that we have. Now, I forgot to put units on the XY axis, so we're going to add them on here. Our Y axis is our height, and we're going to make this be kind of out in the real world or movie. So we're going to say that the height is in feet. So it's how high the Angry Bird goes. Our x-axis is going to represent horizontal distance, and that will also be in feet. So how far that Angry Bird is away from that start. So we have two equations here that model the paths of the two different angry birds that we have. What is the same about the two equations? The C value. In both equations, C is 3.5. What does this number represent? Yep. The y-intercept. You're exactly right. Now, since this is also a word problem, we want to think about what is this 3.5 in relation to the angry birds. It's the starting height. That's right. If it is a y value, it's got to deal with the y-axis, which is the height, and it's our starting height or our initial height. So this is the starting height of the angry birds. Is 3.5 feet. Once you've written that down, go back to that yellow sheet where it says y-intercept in that box, and let's add what that means when you see a word problem. So y-intercept dealing with words is the starting. And it could be height or it could be something different. So this is the starting value. Bless you. Some people also call it the initial value. Bless you again. Bless you. Also, right above that, you probably already wrote this, but it's when x equals what? 0. So when the horizontal distance was 0, the starting height of the angry birds was 3.5 feet. But a lot of people talk about it as the starting value or initial value. But remember, it's a y value. Okay, part B is where we're going to get into a lot of kind of messy stuff here. That's why I tried to leave you a lot of room there to write this stuff, because this one says find the x-intercepts. So look at your yellow sheet. Well, we're going to use the first equation here. The second equation is actually going to be later, but the first equation is in what form? Standard. And we want to find the x-intercepts. So we need to use what? Quadratic formula would be the best. I wouldn't use complete and square or factoring, and you can't use square roots. So we're going to quadratic formula this long mess here. It's going to be a lot of decimals, but we're going to use our calculator to help. So before we do quadratic formula, let's pick out our A, B, and C. So what's A? Good, negative 0 point. And B, 1.156. And C is 3.5. And then all together we can sing our song. X equals opposite of B plus or minus square root B squared minus 4AC all over 2A. Yeah, it looks really long, especially with all of those big, long numbers in it. But remember, this is a word problem, so rounding is fine. We can do a lot of rounding in here. But we still simplify the same way that we simplified it in the last unit. What do you simplify first? Denominators. So we have 2 times negative 0.0516, which gives us negative 0.1032. And then we simplify what's under the square root. So we have now this gives us lots of decimals here, so we can round this to a few decimal points if you want to make it a little bit easier to deal with. I think in first period we rounded to 4 because the other numbers had 3 or 4 decimal places. So 2.0587. Now what I'm going to do is I'm going to go ahead and divide both of those but not add them yet, because normally we simplify what's under the square root, but we're not having to break that down because we don't need an exact value here. We're just estimating for our word problems. So let's divide those two fractions. Oh, negative, or yeah, 1.156, sorry, divided by negative 0.1032. So I get about 11.20. I'm just going to say 11.2. And then plus or minus, yes. It is. I haven't divided already. Let's see. Oh, yep. You used the negative key instead of the minus key right there. So now you got the same one. All right, then let's divide that out. Remember, alpha y equals inner. That can give you the fraction look to it. So it was square root of 2.0587. And then over that denominator, and I get negative 13.90. So you kind of got to go slow on these with all of those decimals. But just type it in and just be real careful of how you type it in. So now we have the plus or minus, which we could split up into 2 problems, and we could add and subtract. So 11.2 plus negative 13.9, 11.2 minus negative 13.9. Remember, the minus the negative will change to plus a positive, and so that way you could kind of fix those. So we get negative 2.7 and 25.1. I know that was a lot of decimals to type in, but make sure that you write down kind of how to simplify it so that way you can get similar numbers. Now, once you have those numbers, those are our x-intercepts, but what do the x-intercepts represent? It's kind of the B and C in the formulas. What did you say, Wesley? The landing points. It is actually where it hits the ground, right? If you look back at the picture, you can see it a little bit easier. So negative 2.7 is this point here, and then 25.1 is this point. Actually, it's this point with the other line, but it's where that graph is going to end up hitting the ground. So if we want to describe this in words, which number would be more appropriate to talk about? The 25.1. So we could say the Angry Bird hits the ground at 25.1 feet from the starting point. Because the x value represented that horizontal distance, so make sure you know what x represents. A lot of times, x will represent time, though. This negative 2.7, that would be going in the opposite direction, and that's if, you know how when you did the Angry Birds before, did y'all pull them back too far and then they kind of fell off, they went and like fell backwards? Yeah, so that's when your Angry Bird falls backwards at that negative 2.7 feet away. All right, go back to your yellow sheet that you have and look at that box that says x-intercept. Some key words to help you know that you're finding x-intercept is when it says hits the ground. That's a key thing. Anything that talks about hitting the ground, if there's a lake, maybe splashing in the water or something like that. Another key phrase that you might see later on your homework, hint, hint, is the width at the ground. Maybe the width of the parabola. We did widths of once. It's been a while back. Do you remember how to find the width of something if you have two x-intercepts? You add or subtract depending on what numbers that you have. So think about the distance from one to the other. All right, two more questions real quick. Part C says find the vertex. Well, we actually already started finding the vertex, didn't we? What's the little equation that helps us with vertex? Opposite of B over 2A, which we already found to be 11.2. So our vertex is 11.2 comma what? So to find the y value, what do we do with that? Plug that in for x. So we're doing 11.2 stores x and then type in our equation, which was negative 0.0516x squared plus 1.156 plus, oops, forgot the x, plus 3.5. So be careful, type it in slow, unlike I did. So the y value would be about 9.97. So what does the vertex represent? The max or the min. Now in this case, is this graph showing us a max or a min? It's showing us a max because think about the equation. If the a value is negative, how does it open? It opens down, so our vertex would be a max. So let's explain it the same way we explained in the first problem on your sheet. We could say at and talk about the x value. So at 11.2 feet from, the next problem I called it a catapult, so I'll just use a catapult. At 11.2 feet from the catapult, you could also just say the start value. The Angry Bird is at a max height of 11.2 feet. Key word in there is when you describe the vertex, use the word max or, oh, I don't know, 9.7. Sorry about that. Thank you. 9.7. Should be at the y value. I saw 11.2 so many times, I just kept going with it. Everything's 11.2. But at 11.2 feet, so at that x value, we reach the max height at that y value. All right, last problem here. How high is the Angry Bird when he is 16 feet from the catapult? So what is this 16 talking about? It's the x value. It's saying it's 16 feet from the catapult, so this is the x value. So it's giving us an x. What do you think it wants us to do? Find y. How can we find y? It looks like it's 5 on the graph, but how do we find it by hand or maybe with a calculator. Plug it in. That's right. So you can do 16 store as x. I had my equation typed in before, so I'm just going to up arrow and hit enter on it to pull it back. So at 16 feet, it's actually a little bit higher, so it's about 8.79. It could be that, were you looking at the dotted line? Yeah, so look at the solid line. Does that one fit better with the solid graph? There we go. All right. For the rest of class, which you guys have about 20 or about 30 minutes, you are going to be given one problem, and I want you to work in your group and answer the problem. When you get it done, check it with me, and I'll give you the next problem. This is also part of your homework, so do it on your homework sheet.